A beach is a landform alongside a body of water which consists of loose particles. The particles composing a beach are typically made from rock, such as sand, gravel, shingle, pebbles, etc., or biological sources, such as mollusk shells or coralline algae. Sediments settle in different densities and structures, depending on the local wave action and weather, creating different textures, colors and gradients or layers of material. Though some beaches form on freshwater locations, most beaches are in coastal areas where wave or current action deposits and reworks sediments. Erosion and changing of beach geologies happens through natural processes, like wave action and extreme weather events. Where wind conditions are correct, beaches can be backed by coastal dunes which offer protection and regeneration for the beach. However, these natural forces have become more extreme due to climate change, permanently altering beaches at very rapid rates. Some estimates describe as much as 50% of the Earth's sandy beaches disappearing by 2100 due to climate change-driven sea level rise. Sandy beaches occupy about 1/3 of global coastlines. These beaches are popular for recreation, playing important economic and cultural roles, often driving local tourism industries. To support these uses, some beaches have man-made infrastructure, such as lifeguard posts, changing rooms, showers, shacks and bars. They may also have hospitality venues nearby or housing, both for permanent and seasonal residents. Human forces have significantly changed beaches globally. Direct impacts include bad construction practices on dunes and coastlines, while indirect human impacts include water pollution, plastic pollution and coastal erosion from sea level rise and climate change. Some coastal management practices are designed to preserve or restore natural beach processes, while some beaches are actively restored through practices like beach nourishment. Wild beaches, also known as undeveloped or undiscovered beaches, are not developed for tourism or recreation. Preserved beaches are important biomes with important roles in aquatic or marine biodiversity, such as for breeding grounds for sea turtles or nesting areas for seabirds or penguins. Preserved beaches and their associated dune are important for protection from extreme weather for inland ecosystems and human infrastructure. Although the seashore is most commonly associated with the word beach, beaches are also found by lakes and alongside large rivers. Beach may refer to. The former are described in detail below. The larger geological units are discussed elsewhere under bars. There are several conspicuous paths to a beach that relate to the processes that form and shape it. The part mostly above water, and more or less actively influenced by the waves at some point in the tide, is termed the beach berm. The berm is the deposit of material comprising the active shoreline. The berm has a crest and a face, the latter being the slope leading down towards the water from the crest. At the very bottom of the face, there may be a trough, and further seaward one or more longshore bars, slightly raised, underwater embankments formed where the waves first start to break. The sand deposit may extend well inland from the berm crest, where there may be evidence of one or more older crests. Winds shape the feature. Where wind is the force distributing the grains inland, the deposit behind the beach becomes a dune. These geomorphic features compose what is called the beach profile. The beach profile changes seasonally due to the change in wave energy experienced during summer and winter months. In temperate areas where summer is characterized by calmer seas and longer periods between breaking wave crests, the beach profile is higher in summer. The gentle wave action during this season tends to transport sediment up the beach towards the berm, where it is deposited and remains while the water recedes. Onshore winds carry it further inland, forming and enhancing dunes. Conversely, the beach profile is lower in the storm season due to the increased wave energy and the shorter periods between breaking wave crests. Higher energy waves breaking in quick succession tend to mobilize sediment from the shallows, keeping it in suspension where it is prone to be carried along the beach by longshore currents, or carried out to sea to form longshore bars, especially if the longshore current meets an outflow from a river or flooding stream. The removal of sediment from the beach berm and dune thus decreases the beach profile. If storms coincide with unusually high tides, or with a freak wave event such as a tidal surge or tsunami which causes significant coastal flooding, substantial quantities of material may be eroded from the coastal plain or dunes behind the berm by receding water. This flow may alter the shape of the coastline, enlarge the mouths of rivers and create new deltas at the mouths of streams.